everyone. Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, now as we discussed, we are going to start with our discussion talking about a few properties that every transaction should follow. And we compile those names and call them as ACID properties. Okay. So every transaction has four properties and they're basically used to maintain consistency in a database before the transaction and after the transaction as well. So we want to make sure that a transaction should never leave a database as inconsistent. Okay. So for that, four properties are there. A is for atomicity, C is for consistency, I is for isolation, and D is for durability. Let's talk about them in detail. So when we talk about atomicity, it basically states that all the operations of a transaction takes place at once, and if not, the transaction is aborted. Okay, so all the transaction has to be executed one after the other, right? And they have to either fully execute or they don't execute at all. So there is no concept of half a transaction, right? You cannot do that half transaction I've executed, half I'll do later. No, all of it, all the tasks of our operations are performed at once and they need to be operated as one single unit. Okay, and if not, you simply abort the transaction. So either you fully complete the transaction or you don't do the transaction at all. Like I said in the other way, there is no midway. That is, the transaction cannot occur partially. Okay, each transaction is treated as one unit, and either you complete the transaction, you complete its entire execution, or you do not execute it at all. Okay. Now here, atomicity involves the following two operations. Abort. Now, if the transaction aborts, then all the changes made will be rolled back and they are not going to be visible. Whereas if it is commit, that means that if a transaction commits, then all the changes made are going to be visible. Okay, that all the changes, all the like I would say tasks of a transaction that you've committed, they are going to be made visible. Okay, let's take an example. So the following transaction T consists of T1 and T2 tasks. Okay, A consists of rupees 600 and B is a person who has 300 rupees. Now, if I want to transfer 100 rupees from account A to account B, first I will read in account A, I will deduct 100 rupees from it and I will write back the updated balance. Similarly, I will read account B, I will add 100 to it and I will write down the updated balance in the database. Now, after the completion of the transaction, right, A basically will have 600 because initially it had 600, now it has 500 because 100 got deducted, and B will have 400 because initially you can see it had 300 and now 100 got added. Now, if the transaction T fails, right, let's say here after you did these three steps now, read A minus 100 and write A, the transaction fails. Okay, then what will happen is, it means that money got deducted from A's account, but the money did not get credited in B's account, which is inconsistent state, right? This is inconsistent, where money got deducted from someone's account, but it did not get credited into someone else's account. So this is an inconsistent database state. In order to make sure and ensure correctness of database, the transaction must be fully executed, or you roll back also the part where you deducted money from someone's account. Next is consistency. The integrity constraints, right, which we talked about in SQL, are maintained so that the database is in consistent state before and after the transaction. The execution of a transaction will leave a database either in the prior stable state or a new stable state. Okay, so if you execute a transaction, so you reach a new stable or a consistent state. But if you do not fully complete the transaction, you go back to the previous stable state. है ना? So execution of a transaction can either lead to either of these things. The consistent property of a database states that every transaction sees a consistent database instant. Okay, the transaction is used to transform the database from one consistent state to another consistent state. Okay, always if your database is in a consistent state, if you perform transactions on it, you should ideally go to a new consistent state, right? You never go to inconsistent states during a transaction. For example, the total amount must be maintained before or after the transaction. Okay, if you have 300 someone's to account, and if you have total someone's account before and after, right, you have to make sure that the transaction is consistent. Clear? Consistency as a concept is very similar, right? The database should always be in a consistent state after executing the transactions. Next, what we have is isolation. So the concept of isolation says that the data which is used at the time, right, at the execution of a transaction cannot be used by the second transaction until the first one is completed. Okay, so the concept says that every transaction should execute in such a way that it is not concerned or not even aware of any other transaction that is being executed. Okay, and if one transaction is manipulating some data, the other transaction should not have the access to manipulate that data as well. Okay, that is strictly not at all allowed. Okay, isolation means that everything should happen in an isolated manner where every transaction is thinking that it is the only one that is being getting executed, and it is feeling that no other transaction is getting executed. And no two different transactions can basically, I can say, look at or manipulate a single data at a particular point of time. In isolation, if transaction T1 is being executed using the data item X, then that data item cannot be accessed by any other transaction T2 until T1 ends. So first T1 will execute, it will manipulate the data whichever it wants, and then only after that T2 will execute. T1 and T2 cannot execute parallelly and manipulate a single data item X. Okay, the concurrency control systems of DBMS basically enforces this isolation property. So that's not actually true कि DBMS में कभी you will never find that no transactions are happening in concurrent, right? There are concurrent transactions happening, but you have to make sure that they are happening in isolation with each other. And the last one in this, what we have is durability. Now, the durability property basically indicates the performance of the database consistent state. It states that the transaction made the permanent changes. So you need to make sure that whatever changes you are making in the database are permanent, are durable. It's not like you completed all the steps of the transaction, but after that some failure happened and the changes just went away. So you have to make sure that the durability of the databases is maintained, right? There cannot be a situation where some erroneous operation of a faulty transaction or by the system can lead to the failure. Okay, the data or the states or like the performance of the transaction cannot be lost. When a transaction is completed, then the database reaches a state known as the consistent state. Okay, and that consistent state can never be lost even in the event of a system failure. Let's say you did some transaction, the transaction got into partially committed state, then it got into committed state, right? And after that some system failure happens and that transaction got lost. This cannot happen. Durability concept says that once a transaction is completed, its changes are to be forever maintained, irrespective of the fact that a system failure happened or a hardware failure happened. It does not care about that. Okay, so you have to make sure that the recovery, right? So whenever a system failure will happen, obviously you will lose the data, but your durability or your recovery system of the DBMS should ensure that all of those transactions committed and the changes that happened are recoverable. Okay, so this is what the concept of durability is whenever we talk about transactions in DBMS. Okay, so this basically completes our idea for asset properties. Next, we are going to talk about DBMS concurrency control in the next video. But just to quickly reiterate on what we discussed so far in this video is that every transaction should follow 4 properties. Okay, asset properties. Try to remember it this way. A is for atomicity, C is for consistency, I is for isolation, and D is for durability. Atomic transaction means that either the transaction will fully execute or it will not execute at all. There is no concept of midway transactions. Consistency means that before the transaction and after the transaction, both the states of the transaction or both the states of the database should always be consistent. Whenever you execute a transaction, either it will go to a new stable state or it will go to a previous stable state. Isolation means that if two transactions are happening, they should happen as such no one is aware of the other transaction that is happening as well. And at a time, a particular data item can only be accessed by one transaction. If another transaction also wants to access that data, first it will let the previous transaction complete, and then only it will let the other transaction access the data item. Durability means that once a transaction is completed, its changes are to be sustained forever. No system failure, no hardware failure can actually lead to loss of the database after the transaction. You should have relevant recovery mechanisms put into place to make sure nothing is ever lost. Okay, so this completes our very basic idea about what transactions are and what transaction properties are. In the next video, we are going to talk about concurrency control. What is concurrency control? How do we understand the concept of concurrency control? And what all do you really need to keep in mind while executing transactions? Okay, so all that is going to be discussed in the next few videos that we are going to take up, and then we are going to have a deeper understanding of how the transactions basically are performed there as well. All right, till then, please stay tuned in for the videos. We have few videos left where we are going to discuss some more important topics. Thank you. Have a great day.